Hey everyone, and welcome back to the Virtual Eclipse Community Meetup. I'm your host, Stephanie Swart, and today we have the 9th and final webinar in Eclipse Photon series. As well, as you know, today is the Eclipse IDE release of its new version, Photon. So if you want to grab that, head to eclipse.org/photon and hit the big golden button for the download. And if you want more great content, be sure to scroll through the website and check out all the webinars we've hosted the past couple of weeks for more tips, features, and more in Eclipse Photon. So today I'm joined by Istvan Rath from Inquiry Labs, who is presenting what's new in Eclipse VIATRA 2.0. So without further ado, Istvan, take it away.
Oh, thank you very much, Stephanie. Hi, everyone. My name is Istvan Rath. Like Stephanie introduced me, I'm Managing Director of Inquiry Labs, one of the contributors behind Eclipse VIATRA, the high-performance model query and transformation framework of Eclipse. And in today's session, I'm going to talk a little bit about what this technology is, what it can do for you, and obviously also I will also go into a little bit of details about what's new in the 2.0 version, which is out today as part of the Photon release of Eclipse. Okay, so I'm going to start off with let's say, brief description of what VIATRA is. It's essentially a framework for working with models. So it's part of the Eclipse modeling family of plugins, which are frequently used in model-based engineering and design scenarios that are typically deployed in domains like avionics, automotive, transportation, energy, essentially wherever you need to work with models as well as code when you are designing software-intensive systems. VIATRA is essentially a kind of a middleware, so an enabling technology. It's not something that end users of modeling tools typically interact with, but it's something that developers of modeling tools use in order to make their tools smarter, faster, more efficient. Over the years, VIATRA has been integrated into a lot of end-user modeling frameworks like Capella, the model-based systems engineering tool developed in the context of the Polarsys initiative. VIATRA also has integration to many high-level Eclipse-based solutions like Sirius, the framework for graphical modeling, or Papyrus, which is Eclipse's UML, SysML toolchain. But VIATRA also has been integrated with tools and technologies that are outside of the traditional, let's say, Eclipse domain of tools, such as commercial solutions like MagicDraw, or we even have integration with frameworks like MATLAB Simulink. The two fundamental functionalities provided by VIATRA are queries and transformations. These are basically the fundamental building blocks of modeling applications. So queries you typically use in a modeling tool for assembling contents of UI components or views, or running validation checks on your models, or generating code from your models, which leads us also to the second part of the framework called model transformations, which help the developer with actually processing the model, so doing something with the results provided by the query engine. In terms of technology, VIATRA is essentially a library of features that can be accessed from Java or Java-based languages like Extend. You can create applications like code generators or import-export facilities, validation engines, analytic solutions, visualizations, and so on and so forth based on this enabling technology. VIATRA has several contributors and users, some of which I highlighted on this slide. Some of them are actually large-scale users of modeling technologies. And this is also the reason why one of the primary design principles that we continuously maintain when working with this technology is to make sure that it's as scalable as possible. So VIATRA has been engineered and designed from the ground up to be deployable in scenarios where there are large models ranging from hundreds of thousands of elements or even in the millions range, collaborative scenarios where multiple users are working together on the same set of documents using modeling tools, and so on and so forth. The resources related to VIATRA are primarily hosted on Eclipse website, which is linked here. but we also have our own GitHub organization for projects that are, let's say, add-ons to the core set of functionalities, which are not practical to host at Eclipse, but you are very welcome to check them out and contribute to them as well. So now, after this high-level overview, I'm going to go into a little bit deeper to give you a better idea of what VIATRA is and what it is useful for. I'm going to start with VIATRA Query because this was the, let's say, the first core functionality that has been developed originally about 8 years ago. And this is the query engine, which is called VIATRA Query. So the original motivation for developing such a technology comes from requirements related to large-scale modeling tools that are frequently used in, for example, the automotive domain. Many of you may know AUTOSAR, which is the de facto standardized modeling language used for designing software architectures to be deployed in an automotive system. And AUTOSAR is essentially a big domain-specific language that not only talks about or specifies how the model should look like, but also contains specifications as to how the models should be validated against common design rules or principles that have been set forth in the standard. So originally, we developed VIATRA Query as a technology that caters to expressing these violation rules or design rule checks using a query language that is specifically tailored to the modeling scenario, and also powered by an execution environment which is able to meet this scalability challenge, which arises from the fact that in AUTOSAR you can easily have models that have more than 1 million elements, and you have to run many different design rules on them at the same time. So essentially, the way VIATRA queries are written is to think about the model as a kind of a graph, which is constructed from model elements that you can think of as the nodes of the graph and the relationships or references in between them, which are the edges of the graph. And the query in a VIATRA query is essentially a pattern definition that sort of graphically describes how a particular configuration should look like in the model. When I say graphically, this is mostly the way that you should, when using this framework, think about the specifications. But in reality, as you will see very shortly, these specifications are written using a very rich and fully featured textual language. But before I show you how the textual language looks like, I want to show you how such queries are typically implemented using a traditional language like Java. Your programmer would write something like a nested loop, which iterates over the structure or contents of the model in order to evaluate what are the matching contexts in the model to a particular pattern or query specification. In contrast, the VIATRA query language is a completely declarative language, which means that using the language, you don't describe the way the results of a query should be calculated, but you just describe the way the results should look like. So the declarative specifications are made up of clauses which individually contribute constraint specifications to the definition of the query. This is a principle which is often employed in query languages like SQL or Sparkle. The VIATRA query language strongly builds on such foundations, but it's very tightly bound to the modeling context because the typing information comes directly from the meta model against which these query specifications are written. So everything that you see in the blue highlight on this example is a so-called type constraint, which directly refers to concepts defined by eCore, and all the black and the violet highlights are essentially code words of the language. In this particular case, we see how powerful this language is. So it's very easy to write a so-called multi-step navigation along several relationships or references in this graph. And you can also use an expression language, which is essentially realized using XBase, a Java-like embedded language in Xtext that can be used, for example, to express value constraints on attribute values. This language, or this way of specifying queries, is extremely compact, meaning that typically you get a 1:10 ratio in terms of lines of code for the same logic as expressed in a traditional language like Java versus using the VIATRA query equivalent. The language has very powerful constructs like the calculation of so-called transitive closures or reachability graphs. You can also use recursion, negation. You can embed query definitions into each other. So the so-called expressive power of this language is on par with the traditional database query languages like SQL, or in a sense even more powerful than them, because you can express things which are typically used in the modeling scenario very compactly. On the runtime side, VIATRA actually offers several so-called backends now. So these query definitions are interpreted by these backends in order to calculate the results. These backends actually not only just do interpretation, but they also do optimization strategies as well in order to determine the most efficient way of actually calculating the results of the query. VIATRA actually has three major options for running these queries: the search-based engine, the live engine, and the combination of these engines is called the hybrid engine. These are basically corresponding to different, let's say, optimization sweet spots, which are very useful, especially when designing highly scalable modeling tools. But before any of these query strategies can run, VIATRA actually performs a so-called indexing operation on the contents of your model, because all the calculations are then performed on these index representations. The search-based engine is the most memory efficient version that you typically use when you want to minimize the memory usage of your tool. This is mostly used in resource constrained environments where the amount of memory that can be allocated to one particular workstation is limited. But it still provides a much faster performance in terms of query evaluation speed when compared to a typical implementation that your programmer would create. The most interesting and probably also unique selling point of this technology is the live query engine, which is blazing fast. So it's typically runs under just a few milliseconds, even for complex queries and large models. And it also can provide so-called result change notification. So it attaches itself to the model representation in your tool. And whenever your user is making changes to the models, then the query engine will calculate the results of these changes in terms of the query results on the fly. But obviously, such an execution style requires more memory. So this kind of execution is typically used when the memory limitations are not concerned. And finally, the engine also provides you the ability to combine these execution styles together on a per query definition basis. So it's a very fine-grained kind of optimization that is very useful in advanced scenarios. If you want to learn more about the capabilities of this technology, we've developed a lot of benchmarks over the years. These are all automated benchmarks, so they can be run in a continuous integration or a build environment. And they also generate results and show you how to do this actually in a proper way with from the generation of the input models to the execution of the queries and the interpretation of the results. So here are a couple of pointers on GitHub for people who are more interested in this kind of stuff. Now I'm going to talk a little bit about the transformation capabilities of this technology. This is, I would say, a little less well known, mostly because VIATRA has been primarily known as a query technology, but it's also a very powerful transformation technology. So first of all, just to make it clear what I'm talking about here, so model transformations are essentially pieces of code or programs that perform some modifications on your models. Sometimes these are model-to-model transformation, meaning that both the source and the target, so the input and the output of this code is a model, so a structure of objects. But in many cases, we actually use model transformations for other purposes, like code generation, where the final output of the processing is actually some text or a segment of text serialized in source files, for instance. So this is basically the use case that VIATRA is also very useful to use for. But it's a very specific approach. So it's architecturally and conceptually different from other model transformation frameworks found in Eclipse, like Epsilon or ATL, because VIATRA is basically a reactive engine. So it has been designed on the principles of reactive programming. You can also think of it as a kind of a rule engine for model transformations. And it's an event-driven execution platform, meaning that it operates on so-called observed or controlled events, which are coming from the input side or the source model. And it can also emit notifications or changes or operations on the model, but you can also use it for processing and producing text. And essentially, the specifications that you use for writing transformations against this execution engine is based on the well-known event condition action principle. So this is something that has been elaborated very thoroughly in the context of rule-based systems, but we applied this in order to write very efficient and especially so-called incremental model transformations. These events in VIATRA always correspond to changes in the model. So whenever someone has created a new model element or changed the attribute of one particular property and so on and so forth, or even deleted something, the condition is given by the kind of, let's say, change that has happened, like an appearance of a new result of a query or an update on an already processed property value. And the action is basically a snippet of code that you can write using a language like Extend or Java that can do basically whatever Java and Extend can do. Here is a typical example, just to give you an idea of how these specifications or rule specification look like when working with the transformation API of VIATRA. Here the language that I'm using for this example is Eclipse Extend. And as you can see, it's basically a combination of vQuel, so the pattern definition using our own DSL. And here is an excerpt in the Extend language, which basically implements a kind of a builder design pattern in order to efficiently and compactly assemble the definition of rule specification that refers the pattern definition through its generated code, also provides a condition statement, and here within this segment we have this imperative code where the programmer can make use of an internal DSL that gives access to model manipulation primitives that are very frequently used in model transformation languages, like creation, removal, and so on and so forth of model elements. So in summary, VIATRA is essentially a very comprehensive set of technologies. On the tool side, we have a declarative and powerful query language, which is based on Xtext and Xbase. I didn't talk about in this presentation, but VIATRA also has debugger tooling, which is very frequently used in combination with this reactive execution style. We also have support for continuous integration builds implemented using Maven. So you can, if your project is built using Maven, then you can integrate the VIATRA compiler into that toolchain very easily. And finally, we also have a very comprehensive test framework to generate, for example, coverage support or coverage reports in terms of this query language. On the runtime side, I talked about these high performance options that provide various trade-offs for optimizing your application towards non-functional goals. And it's very important to mention that actually the runtime component of VIATRA is essentially a headless Java library with minimal dependencies. So integrating into any kind of application is very easy. In terms of the APIs, there is a lot of options and a lot of useful features that programmers can make use of when trying to integrate advanced functionality into their applications. And finally, we have a set of high-level add-on frameworks as well that I also didn't mention in this presentation, but they are all featured in the documentation and the website that provide high-level functionality on top of this technology, like model validation, specification of views, which are automatically maintained. We have add-ons for performing so-called design space exploration operations, and so on and so forth. So if you are interested to learn more about these technologies, I would suggest to go to the Eclipse website and then go to the documentation point in the menu, and then from there you will be directed to the appropriate parts of the documentation. So now, after this introduction, I'm going to talk a little bit about what's new in this version 2.0 VIATRA, which, as we said, came out today with the release of Eclipse Photon. Basically, version 2.0 marks a very important milestone in the life of this project, because up until now, we've been producing the 1.x series. I think the latest version of that series was VIATRA 1.7. And for VIATRA 2.0, we wanted to simplify the framework in the sense that we wanted to remove less widely used features in order to reduce the effort required for maintenance, and also make it possible to introduce deeper optimizations and let's say more radical changes into the entire toolchain. Essentially, in terms of simplification, we reduced the third-party dependencies, especially on libraries like Guava, even further to make it even easier to integrate this in technology. And we also introduced a couple of new language features in the query language in order to make usability improvements and make it easier to use. One of the things that we focused on in this development cycle was optimizations, especially on the compiler side. So in the past, if you had a large VIATRA project structure with a lot of projects, it could have taken a lot of time for the compiler to finish. This has been reduced drastically. So if you had problems with this in the past, I definitely recommend you to check out this new version, because you are going to see much faster performance. Equally important is our work on optimization of memory usage. You might remember that I talked about this like a few slides ago, that in the live execution mode, the VIATRA Query engine requires some memory, which obviously with large models can be sometimes significant, and we worked a lot on reducing this. So I can probably say that in some scenarios, up to 80% less memory usage is very typical to see with this new generation of engine that we released in this version. Finally, for a long time, VIATRA has been very conservative in terms of the Java version that was required for using it. We maintained this Java 7 requirement throughout the 1.x series, but for 2.0, we wanted to move into the future. So now Java 8 is a requirement, and it's actually some Java 8 specific features are used on the API, like the streaming API, from which I actually included a small code sample here. And it's fully supported to run this technology on Java 9 and 10 as well. So we actually test in that context as well, and so it's supported. Like I said, VIATRA 2.0 is available today in Eclipse Photon, and the 2.x series in the future will follow the two new feature release per year cadence as before. But it's also important to note that the so-called classic series, so this VIATRA 1.7.x, will be continued to be maintained for backward compatibility. So we are going to continue to provide bug fixes for that, and also maybe some features will be backported if there is demand for that. So for those of you who have some constraints related to the Java version, for example, you can continue to use VIATRA 1.7.x as you did before. Basically, what I would like to talk a little bit more is what's the ecosystem or the context which is expanding around VIATRA technology. And basically, the most important development where VIATRA has been utilized, especially with these new 2.0 features, is the technology that we as a company started working on. It's called Inquiry, which is basically meant as a cloud-based modeling platform that can be deployed in contexts beyond the traditional Eclipse modeling world. Inquiry is essentially a scalable platform for executing queries and transformations on top of models that are stored not only in files and in-memory representations, but in databases and especially distributed databases. And basically, this technology embeds this new generation VIATRA engine in a kind of a microservice-oriented containerized infrastructure that can interact with a number of different repositories, commercial tools, open source tools, model storage platforms, and so on and so forth, using modern technologies like OpenAPI and Swagger interfaces in order to provide the VIATRA style of scalable execution performance on a much larger scale. So basically, this technology is meant to provide a kind of a horizontal scaling opportunity for processing models in a cloud-based infrastructure. And this development is not only based on VIATRA, but also other very nice open source technologies coming from the Eclipse world, like Vertex and Eclipse collections. In the context of this work, we actually did some open source contributions which are directly interesting for users of VIATRA. And I would like to mention just one of these, which is called V4MD, or VIATRA for MatchDraw. MatchDraw is a commercial tool for UML and SysML modeling, but we released an open source adapter library which can be used to integrate the model query and transformation technologies provided by VIATRA into this platform under the Eclipse public license version 2.0. It's available on GitHub under the VIATRA organization. So if anyone is interested to know how this is done and how VIATRA can be used in such a context, they are very welcome to check this out and contribute to that project as well. I would also like to talk a little bit about what we are working on at the moment. Like I said before, there will be a new release called 2.1 due sometime in the fall. And one of the major, let's say, projects that the VIATRA developers are working on is creating a new representation or front end to this domain-specific language, which will be graphical, and it will be based on the most recent version of Sirius, Eclipse's state-of-the-art graphical modeling framework. And this contribution originates from our colleagues and friends at Thales, who have developed, let's say, the original approach or design of this tool and contributed to the project. And we are now picking up on this development and building a fully featured graphical representation for this language. And this is basically tailored to those users who are, let's say, less technical, so less inclined to use this textual language, which looks like kind of a programming language, but more familiar with graphical notation. So this is basically meant as a, let's say, easier entry point into working with VIATRA technology. This work is, done on Eclipse. So if anyone is interested, there is a Gerrit change posted, and you can go there and check it out yourself, and also contributions are very much welcome here as well. So in conclusion, the takeaways of my presentation are, first and foremost, that VIATRA 2.0 is now leaner and faster than ever. There is a very detailed changelog on our website that gives you a walkthrough of all the different changes that we've done. There is actually a lot more to this release than I could talk about in such a short presentation. And we actually worked on not only the code, but improving the documentation as well. So VIATRA now has a very nice end-to-end tutorial which guides you through the beginnings up until the point of creating rather complex solutions based on this technology. There is actually a very nice case study example available on the Eclipse kit that is very comprehensive, so it covers all the different scenarios and use cases that VIATRA can support, and it's featured very deeply in this tutorial as well. So if anyone is interested in VIATRA, I definitely recommend to go to our website and check out the tutorial, because it's very nice. And finally, if you're interested to know more about this, let's say the broader context around VIATRA and some of the tools that we've been developing on top of this technology, I did a session on this very recently at Eclipse Conference. So there is a link on my slide here that you can go and check out. I uploaded my slides there, and I think that the session itself will be available online, or maybe it even already is. So you can actually check it out and listen to that as well. So that's all that I wanted to present today. And Stephanie, I give the word back to you.
Thanks, Istvan. Fantastic presentation. And of course, as always, thank you to our community for tuning in. This concludes our Eclipse Photon series, and we have no questions at this moment in time. So if anyone has any questions for Istvan, feel free to drop them either on the Eclipse YouTube chat box, on Twitter, or on our virtual meetup community page. So again, I'd like to say thank you to Istvan for presenting and volunteering his time, and for our community for following us for the past 2 weeks. This has been a great webinar series. So we will see you again for our regular sessions of the Virtual Eclipse Community Meetup. The next one will be on July 3rd, Eclipse VIA Cloud and Desktop IDE. So thanks again, everyone, and have a great day.